the previous video, we looked at the gradient of a line. Specifically, at the end of the video, we saw how the gradient and the y-intercept appear in the equation for the line. Hence, in this video, we're going to use this information to quickly sketch a few line equations. So, let's start with the first example. Sketch the following lines using their gradient and y-intercept. So example 1, y equals 3x plus 3. Now previously we've sketched a line by plugging in a few x coordinates into the equation, calculating the corresponding y coordinates, and then plotting these points and drawing a line through them. But there is a quicker way. Remember, the gradient is this number here in front of the x. And the gradient tells us how much y changes by when we increase x by 1. And this number here being added on is the y-intercept. This tells us where the line crosses the y-axis. So these two numbers together will allow us to quickly sketch the line. So we start with the y-intercept. We know the line crosses the y-axis at 3, so we can put a point on the y-axis at 3. We know the line is going to have to go through this point. We can then say that because the gradient is 3, that as x increases by 1, y must increase by 3. It has to be an increase because it's plus 3, the gradient, it's not minus 3. So if we start at this point on the y-axis that we've plotted, we go 1 along in the x direction and 3 up in the y direction, we get to this point. So we can draw our line. So we did plot 2 points and draw a line through them, but we didn't have to calculate these points explicitly by plugging in their x values, pulling out their y values. We could just use the gradient and y-intercept, which we already knew from the equation. Let's try a second example. Y equals minus 1 minus x. So this isn't quite in the standard form for a straight line equation, but we can rearrange it by just swapping the minus 1 and the minus x around. So we have y equals minus x minus 1. Now we can see that the y-intercept in this case is minus 1. So again, we can put a point on the y-axis at minus 1. And the gradient, the number in front of the x, is once again minus 1. So that's telling us that as we increase x by 1, y decreases by 1 because we have a negative gradient. So if we go 1 along the x-axis and 1 down the y-axis, we get to this point. So this is our line. We can try a third example now. Y plus 3 equals 1/3 x. Once again, we need to rearrange this equation slightly to get it in the standard form. So we just take this plus 3 over to the right hand side and it becomes a minus 3. So we get y equals 1/3 x minus 3. So the y-intercept is minus 3. So let's put a dot on our y-axis at minus 3. And now at this point we need to be quite clever. So the gradient is 1/3. That means that as we increase x by 1, y increases by 1/3, but it will be hard to accurately sketch this point if we move 1 along the x-axis and then 1/3 up the y-axis. It'll be hard to do accurately. What we note instead is that if x increasing by 1 corresponds to y increasing by 1/3, then x increasing by 3 must correspond to y increasing by 3/3 or 1. 3/3 is 1. So as x increases by 3, y increases by 1, so we go 3 along the x-axis and 1 up the y-axis to this point here. And hence this is our line. And we'll just do one more example. So example 4, minus 4y equals 30. Once again, we want to rearrange this to get it in the standard form. And the standard form always has y on the left hand side of the equal sign by itself and everything else on the right hand side. So let's take this minus 4 over to the right hand side and we get y equals minus 30 over 4, so we've divided both sides by minus 4, we can simplify this fraction down a bit and it equals minus 15 over 2. So y equals minus 7.5. That's 15 minus 15 divided by 2. So this looks a bit strange at first. Essentially, we don't have an x term, which means that it's the same as saying 0 times x. So the number in front of the x is 0, which means the gradient is 0. And the y-intercept is minus 7.5, because that's the number being added on. So we can put a red point on the y-axis at minus 7.5, and then we know that as we increase x by 1, y doesn't increase or decrease, it just stays the same, so the line must be flat. So this is the line for the equation y equals minus 7.5.
Through the night, happy, I, and his happiness was one with hers.